So moving forward. So today we will see the computer vision library, the famous one, OpenCV. So before starting, I would like to ask you guys, how many of you are familiar with OpenCV, or you are a newbie? So type yes if you are familiar with the OpenCV, or type no if you are new to this field. Okay. Okay, we can see many yes and many no also. So no issue. I will cover from basics to advanced. So yeah, great. So we will start with the introduction of the OpenCV. So first I will introduce you what is OpenCV. OpenCV is a open source computer vision library. Now I think I hope you guys are aware what is computer vision. For those who don't know what is computer vision is a field of study uh, in which we deal how can a computer can get a high level intuition from the digital images, videos, how can be able to make the computer understand the images. So it is widely used for a image processing purpose. The library which we are going to talk about, OpenCV. So here are some technical things about OpenCV. OpenCV is written in C and C++. It is very fast and efficient. Basically used for a image processing task, video processing task. So in Python, we have a lot of many libraries. We have Pillow for for image processing. We have Scikit image. We have Matplotlib. But the point is, why we use OpenCV? Do you guys know about it? What's the major advantage of using OpenCV? You can write in a chat box. Okay. I can see no. Okay. Yeah, we do play with the images, I guess, but we have other libraries also. What is special about OpenCV? Can someone guess? Okay. Let me take it. Yeah. We do image detection also using OpenCV. So I will introduce you. OpenCV is the, we can see. Yeah, open source, it is correct. So OpenCV is a open source library. The other libraries below, Scikit-image, they are also open source. So the main reason why we use OpenCV is that it is one of the oldest library we have. OpenCV has served developers in a computer vision for a very long time, and it has 2500 plus functions in it that help us to do the image processing task. So that's a major advantages of using the OpenCV. Okay, and it is very fast and it is efficient, and it is written in C++. So that is the technical knowledge. That is why it is fast and efficient. Anyway, anybody is saying something?
I request people to put themselves on mute if you do not have any doubt.
Okay, so it's portable. It can run on any device that can run. Do anyone have any doubt?
No, I guess I Simarjit. I'm putting her on mute. Okay, let's go ahead.
So we will see some applications of the OpenCV. So here in this frame, you can also see we have an image which is basically classifying the faces for us. So this scene is taken from the Jurassic Park. For a human, you can see these are the faces, but how can a computer can learn these things? So we have to make the algorithms to work that. So okay, moving forward. So we will see real-time applications of the OpenCV. First is very basic face detection. We have image. We put it into a classifier. OpenCV is a hard cascade-based classifier. We will talk about it in our later session. So you put this image into classifier, and the classifier give you a bounding box around your face. So that's cool. Now your model knows what is face and what is not, because and now we have the real-time application of it. This is the camera frame, which we basically use in our day-to-day life. We used to click the camera, we used to click the image through the cameras, and your camera can identify, uh, yeah, this is the image, this is a face of an man or a woman. It can also give you the age. So that's awesome, I guess. So now moving forward, we have face landmarks. So we can also get face landmarks using the OpenCV and MediaPy. So let me tell you one thing. OpenCV is basically used for image processing, and this thing is done by using a classifier. So basically, for building a classifier is the second thing, but first we need to pre-process the image. So OpenCV help us in this task. So I hope you guys are clear about it. So now moving forward, we have face recognition. In face detection, we are only detecting the face, but we can do further improvement, and we can also recognize who's the face belong to. So moving next, we have a cam scanner we used in our daily life. So we can segment out the document using the OpenCV as well. And this is one of the famous object detection algorithm, YOLO, which is basically used for object detection. And basically for image processing task, we prefer to use OpenCV. So many more applications, guys. OpenCV is very vast. It's like a sea. So, and if you are going to build any OpenCV computer vision application, then you have to work on image processing first. So open computer vision combining with image processing and machine learning can have the application in these different fields. Neurology, we can have in mechanical department also the self-driving cars. We can have many more applications, guys. So this is all about the applications of the OpenCV. Now we will see the table of the content today, what we are going to study. So we are going to see how we can read the image, write the image, display it, what are the color spaces in an OpenCV. Yeah, we will go with it. Here it's unsupervised and unsupervised learning, right? Differentiating image colors. We will cover it in our stages. Okay. So image processing. So we will mainly talk about the image processing part in our OpenCV. So we will see how to read the image, how to write it, what are the color spaces, what is resizing, rotation, how we can do it, what's the necessity of doing the resizing, rotation, what is thresholding, image enhancement in our OpenCV, blurring, edge detection, contour detection, bitwise operation in our OpenCV, morphological operation in our OpenCV. And at the end of the session, we will cover two applications of the OpenCV. The first is face detection. The second is road lane detection, which we use in the self-driving cars. So moving forward. So reading, writing, and displaying of the image. So human being has a capability to see the image. So you see this image, the neuron got fired in your brain. So it says, yeah, it's a green capsicum. But how a computer can see the image? I guess everyone knows that the answer. So the answer is array of the pixels. So this is the pic. The computer can see, yes, this is a pic, and we have a array of the pixels corresponding to this pic. The computer doesn't know whether this is a capsicum or this is a not, this is a banana or anything else, but it knows that this is the image and we have an array of pixels corresponding to that. So the first stage to building any classifier is to read the image. So how we can read it? So in OpenCV, we have a IMRead function that help us to read the image, and IMSo function to output the image. We will see the implementation part also along with. So since this is a RGB image, it has 3 channels. The one go for R, the second is for B, and third is for green. RGB stand for red, green, and blue. So this part of the image has these pixels, right? So moving forward, so this is how we can implement it. So first we need to import the OpenCV library. How we can do the import? We can import the CV2. Here I import the CV2 as CV. The command we basically use for import the library is CV. I guess I know you guys are aware of that. So this is the image. I specified, you have to specify the path of the image, and this is, and you can use IMSo to show the image. So this is how the image looks like. So the most important thing is the IMRead function in the OpenCV read image in a VGR format. We have other libraries also. Other libraries use RGB format, like Matplotlib use RGB format. So that is the important thing to remember, that IMRead function read image in a VGR format. We can also pass extra flags in a IMRead function in order if you want to learn the, if you want to read the image in different format. So we have cv2.imread_color, that is the default, and imread_grayscale, that is if you want to read the image in a grayscale format. So, and this is imread_unchanged. So basically, if your image have some sort of transparency in it, then you need to include one more additional channel that is called alpha channel. So that's where we use the imread_unchanged flag. So this is all